Well, unless I fixed it already, on your handout, I accidentally put the answers on it, or who knows what I was thinking, so I just scribbled them out here and I'll erase them as we do it. So let's read this example. A brand of necklaces is made up of different colored beads. The ratio relationship of the different colored beads is constant for all the different sizes of necklaces. The relationship of the different colors is as follows. So when there's 3 red beads, there are 9 green beads and 4 blue beads and 12 white beads. How many beads are there in total if the smallest necklace that can be made, which still holds this relationship to be constant? Well, none of these numbers, you can't reduce these numbers. You can't divide the same number out of all these numbers. So this ratio cannot be reduced anymore. So that's the smallest ratio we can have for this necklace. So the total would be the 12 plus the 4 plus the 9 plus the 13. So that's 12 plus 16, which is 28. So let's get our eraser. Oops. So that's where that total comes from. Now for B, how many of each color would be in a necklace that has twice the length of the smallest necklace? Well, this length has a total of 28 beads. So if we have a necklace that's twice the length, then that would be 56 beads altogether for the total to be twice the length. So the question is, how many of each color would be in a necklace that has twice the length? So in order to get from here to here, we multiplied by a K, constant of proportionality of 2. So you would multiply 28 by 2 to get 56. You multiply 12 by 2 to get 24. You multiply 4 by 2 to get 8. You multiply 9 by 2 to get 18. And you multiply 3 by 2 to get 6. So that means there are 6 red beads, 18 green beads, 8 blue beads, 24 white beads, and 56 total beads altogether in a necklace that has twice the length of the smallest necklace. So part C asks, how many of each color would be in a necklace that has 3 times the length of the smallest necklace? So let's erase all this. Now here you can see underneath I had when k equals 2, I have all your numbers here that we just found. So the next one says when you have 3 times the length of the first one. So you're going to multiply 28 times the k of 3 to get 84. And then 12 times 3 is 36, 4 times 3 is 12, 9 times 3 is 27, 3 times 3 is 9. So that's how we get a necklace that's 3 times the length of the original. And then you'd have 9 red beads, 27 green beads, 12 blue beads, 36 white beads, and 84 total beads is how many of each color would be in a necklace that has 3 times the length of the smallest necklace. Part D says, in case you haven't already done this, because it didn't specifically tell you to, write the new rows for the numbers above, 1 row for each necklace. So let's erase this again. So now we have 1 row for the smallest necklace. This is a row for the necklace that's twice as long, and this is a row for the necklace that's 3 times as long. And E says write the K value, constant of proportionality, for each new row of numbers. And that's what we did right here. The end.